Deep in the German woods, scientists are preparing for a journey to the center of the Earth. They're drilling deep into the ground with plans to go further than ever before. But why do they want to get so deep? And what might they find down there? Earth is full of surprises. Some are pleasant and some not so much. The core makes up about 46% of our planet's radius. But despite its importance, we still know relatively little about it. After all, it's really hot down there. Temperatures can reach as high as 5,200 degrees Celsius. That's more than 10 times hotter than the surface of the sun. Our best guess is that the core consists mostly of iron and nickel. But to prove that, we need to dig deeper than we ever have before. So in the early 1970s, scientists came up with a plan to get as close as they could to the center of the Earth. They would use a drill that was capable of boring through the toughest rocks. It would be called the German Advanced Research Project for Deep Drilling, or in German, the Forche K Khoan projects, Forche K Khoan for short. On March 6, 1975, work began on the project at a former potash mine near the town of Gütersloh. There were 2 shafts, one of which extended 8 kilometers deep into the ground. Using special techniques and new equipment, scientists were able to bore even deeper, breaking through layer after layer of rock. As they drilled, researchers measured the temperature every 10 meters. At first, the temperature rose steadily, but then something strange happened. Just before they reached the bottom, the temperature suddenly shot up. In fact, the last 10 meters took them from 170 degrees Celsius to 180 degrees Celsius, almost like stepping into a sauna. Scientists weren't sure what to make of this. But by the time they got back to the surface, they had an idea. The temperature spike wasn't due to any nearby volcanic activity. Instead, it seemed to be coming from deep within the Earth itself. The results of the project were published in Nature magazine. And since then, scientists have been trying to solve the mystery of the sudden temperature spike. In 1992, another group of scientists set out to solve the mystery. They returned to the same mine and used a new technique called the thermal conduction method. This method allowed them to measure the temperature of the Earth without having to drill as deep. The results were surprising. The Earth's temperature didn't increase gradually as they went deeper. Instead, it rose very quickly over the last few kilometers. This suggested that the inner core was much hotter than the outer core, but nobody was quite sure why. By 2008, scientists had a better understanding of how the Earth works. They knew that there were 3 main layers inside the planet: the crust, the mantle, and the core. The crust is the outermost layer, and it's divided into 2 parts, the oceanic crust and the continental crust. The oceanic crust is thinner and denser, while the continental crust is thicker and less dense. The mantle is the thickest layer of the Earth, and it makes up about 84% of the planet's volume. It's also divided into 2 parts, the upper mantle and the lower mantle. The core is the innermost layer of the Earth, and it's divided into 2 parts, the outer core and the inner core. The outer core is liquid, and it's responsible for generating the Earth's magnetic field. The inner core is solid, and it's made mostly of iron and nickel. Scientists now think that the temperature spike that the team detected in 1975 was due to a combination of factors. First, the drill was generating a lot of heat. This heat caused the rocks around the borehole to expand, which created cracks that allowed water to seep in. The water then flowed into the cracks and mixed with the hot rocks. This reaction released a large amount of energy, which caused the temperature to rise suddenly. But this is just one theory. Another possibility is that the temperature spike was caused by the drill hitting a pocket of hot magma. Magma is molten rock that's found beneath the Earth's surface. It's usually generated when rocks deep in the mantle are heated by the Earth's core. If the drill had hit a particularly hot pocket of magma, it could have caused the temperature to rise suddenly. Whatever the cause, the temperature spike was a valuable discovery because it gave scientists an unprecedented glimpse into the workings of the Earth. It also raised a lot of questions about what else might be lurking in the planet's interior. Scientists were eager to learn more, but they needed a bigger, better drill. Enter the European Union's Integrated Project on the Physics of the Earth's Core, or EPIC for short. Starting in 2003, EPIC built the world's deepest borehole in the same mine where the original project had been conducted. It took 3 years to drill, but by 2008, the hole was complete. It was 12 kilometers deep, and it was named after the Roman goddess of the earth, Terra. Now that they had access to the deepest hole on Earth, scientists were eager to put their new theories to the test. One team of scientists lowered a device called a seismometer into the hole. A seismometer is used to detect earthquakes. By recording the strength and timing of different seismic waves, scientists can learn about the composition of the Earth's interior. The team hoped to detect a seismic wave that was generated by the Earth's core, but they were surprised to find that the waves they recorded were much weaker than they expected. This suggested that the inner core wasn't as hot as they thought. In fact, it was probably closer to the freezing point of iron, but that wasn't the only surprise. The scientists also detected a seismic wave that they couldn't explain. It was much faster than the speed of sound, and it seemed to be coming from the outer core. The team was baffled until one of the scientists, Gary Stein of the University of California, had a brainstorm. What if the fast seismic wave wasn't coming from the outer core at all? What if it was coming from the boundary between the outer and inner core? Stein and his team proposed that the inner core had a thin, strong outer shell. This shell was so strong that it could transmit seismic waves faster than the speed of sound. While this discovery didn't tell us anything about the actual temperature of the inner core, it did show that the boundary between the outer and inner core was sharper than scientists had expected. This could help researchers better understand the structure of the Earth's core and how it interacts with the rest of the planet. Scientists continued to study the data from the EPIC project long after the drilling was completed. In 2012, for example, researchers used the seismic data to create a 3D model of the inner core. They found that the inner core was not uniform, but had a number of large and small features. Some of these features were blobs of lighter material that had risen from the outer core. Others were cracks that had formed as the inner core cooled. These findings were important because they showed that the inner core was more dynamic than scientists had previously thought. It wasn't just a static ball of iron and nickel, but was constantly changing and evolving. And that's not all that scientists have learned from the EPIC project. In 2015, researchers used the seismic data to study the behavior of seismic waves as they passed through the Earth's interior. This allowed them to learn more about the composition of the Earth's mantle and outer core. They found that the mantle was less rigid than they had expected, and that the outer core was more rigid than they had predicted. These findings have important implications for our understanding of the Earth's structure and how it works. They also suggest that there's still much more to learn about our planet. The EPIC project was a major success, but it left scientists wanting more. That's why, in 2017, they announced plans to drill even deeper into the Earth. The new project, called the German Research Center for Deep Geothermal Energy, or DFG for short, aims to drill a borehole that's at least 10 kilometers deep. The goal of the project is to learn more about the Earth's interior and to find out if it's possible to harness geothermal energy on a larger scale. Geothermal energy is produced by the heat from the Earth's core. It's already used in some countries to generate electricity, but it's typically only used in areas where there's a lot of volcanic activity. The DFG project could change that by providing a cheap and efficient way to tap into the Earth's heat. The project is still in its early stages, but scientists are already making progress. In 2019, they announced that they had successfully drilled a hole that was 9.5 kilometers deep. It's not clear what the scientists will find when they reach the center of the Earth, but they're hoping to make some groundbreaking discoveries. Maybe they'll find evidence of life, perhaps even alien life, or maybe they'll find something else entirely. Whatever they find, it's sure to be an exciting adventure. And who knows, maybe one day we'll be able to harness the power of the Earth to provide clean energy for our planet. but that's just a theory. A scientific theory. I'm your host, and you've been watching this channel. Don't forget to keep on thinking.